I was going to solve for x, though, is it fair to say that what I want to start with is combining like terms? Okay. So the idea if I want to solve for x means I'm trying to get x alone, right? Well, in order to do that, I first have to get the weird thing that's happening to the x alone. In other words, the x squared. I can't get x alone. Thank you. Did she understand what I needed? Riley, did she understand why I sent you?
She didn't question.
Okay, sweet. We got to get the x squared alone, okay? So to do that, I'm going to start by combining my like terms here and here. And then undoing my PEMDAS, right? Until my x squared is by itself. Is that fair? I can't get my x alone until I've gotten the x squared alone, right? Okay. Now what do I do? There we go. And x is 4?
Plus or minus.
There we go. I thought I was going to have to bring that up. Great work, Sid. Is that all right? Any questions? Okay, so now let's go ahead and see how that applies to what we've been doing with logs, okay? If I want to solve for, let's look at this one. The weird thing happening to the log is, the weird thing happening to the x is the log, right? So what should I do before I do anything else to get that weird thing alone? If the -4 was in the log, it'd have parentheses. So I have to add the 4. Good, Nathan, I have to add the 4, right? So I can't get the x alone. What? That doesn't make any sense. There we go. Right, I can't get the x alone until I've gotten the weird thing happening to the x alone, right? Okay, then I can do my log exponent conversion from 7.1. I'm just going to write it again right here. So x equals 3 to the 9th. That one is pretty big. You can use your calculators to find it for me. So what's x? C? What's 3 to the 9th is what I'm asking? 19683. Okay. Okay. Does that make sense? Where I got my exponent conversion? Okay, let's try another one. What should I do to get rid of what's happening to the x on B? Good, divide by 5. So 2 to the 7 minus x equals 8. Can't divide by 2 because now the x is stuck to that. But just like what I did up here where I have to get the weird thing happening to the x by itself before I can get x by itself, right? That's what I've done. I've gotten the weird thing happening to the x by itself. So now I can do my log exponent conversion. So what's my log base going to be?
2.
Good. 2 of 8 equals 7 minus x. Then I think back to 7.1. What exponent do I put on 2 to get to 8? Try again. That's multiply. 3. So 3 equals 7 minus x. So negative 4 equals negative x. So x equals 4. How are we doing, okay? Okay, let's do one more of this type. It's a little quieter than normal in here today, so I just want to make sure you guys doing all right. Like, understand what's going on? Because today's our easy log solving day. So it's going to get harder on Tuesday or the Wednesday.
Oh, don't say that.
Well, I'm just being honest. Summers keeps it 100, right? All the time. I know.
Not.
We have to. What's the log base when it's ln? E. So this one, when I do my log conversion, it's e to the 0 equals the square root of x minus 8. And anything to the power of 0? Ah. And here I can just solve it like a regular equation. How are we doing so far, okay? Now, this is called solving by the log exponent conversion. That's a pretty complicated and annoying name, right? But at least it's clear on what it is, right? Solving by the log exponent conversion. We can do that when one side is a log or an exponent and the other side is just a whole number, okay? The problem happens when we get to ones like A. But I bet if you look at A on number 6, you probably can guess what X is. Anyone have any guesses what X is? Caden? 11. That's true. Okay, I'm going to show you why it's 11 mathematically, but I bet your process of like logic and reasoning, if you look at it, isn't it clear X is 11, right? Okay, let me show you technically why X is 11. Okay, what we're doing is if I want to get rid of, let me write something here. This is just random. X plus 1 equals 5. If I want to get rid of the 1 so that I'm isolating the X, I need to apply the inverse of what's by the X, right? So the reason I subtract is because it's the inverse of addition. Should I subtract 3? Should I subtract 4 to get X alone? Just 1. You have to do the opposite of the exact same thing here. Does that make sense? Okay, so same idea here. If I'm trying to get rid of a 4 exponent, I have to use its inverse, which is a log. But I have to use a log base that's the same so that they cancel. So technically what I'm doing is the inverse of the exponent, which is the log. And then I use base 4 so that these were the same number so that they cancel, just like the 1 and the negative 1 up here, right? But if I do something to one side of an equation, I have to do it to the other too, right? Okay, so that's why mathematically X does equal 11, right? Now, it was easy to see that, but they're not always going to be that easy. So that's why we did one like that. I have more examples of the log ones on later pages. So for workroom, you can cross those off, okay? Okay? Okay, let's try another one here. Okay? How do I get the x down? The only way to get the x down is to cancel that 5 exponent, right? So I have to use a log. What log base should I do? Good. And if I do it to one side, I got to do it to the other. Yep. Okay, let's just pause here for a second.